So here we go. I'm going to make Emma. Tell me what you would say for number one. You all agree with her statement. Rate of a population growth in the city for 4 years.
No.
Bridget, what would you say? So you said instead of the rate of population growth, you said the total growth. So you said the total population growth in the city for 4 years. Bridget, is that what you said? You everyone agree with that? Okay, I am close to agreeing to this. I have an issue. Nick, what did you say?
What it says right now is it can be any 4 years, and the question is referring to the first 4 years.
Oh, so you have to say one of two things, because he's exactly right. What we have here, if you just say 4 years, what 4 years are you talking about?
First 4 years.
Then you need to say for the first 4 years. Or, instead of this, you could say from 0 to 4 years. Either one. Okay? Gabe, what's your group say for example 2? This is what Gabe said, the distance covered from the 3rd to 5th hour. Do you all agree with him? I kind of do. What? What about miles? Oh, so perhaps instead of saying this all the way, what I would say would be the distance covered in miles from the 3rd to the 5th hour. Is it important to have miles in there? Yes. You must have your units of measurement. The AP exam has started to ask a lot of these questions. What does this mean? Interpret this. So do you recognize that when I talk about velocity, that is the derivative? That's the rate of change. And I integrate rate of change, I get position. So I'm talking about the distance covered. Or could I have said the distance traveled? The travel distance. Could I have said the total change in distance in miles? Yeah. I could have said instead of distance covered, I could have said, you could have said the total change in the distance of miles from 3 to 5 hours.
Did you say total miles?
No. Because if you say the total miles, what happens if I had gone backwards? That doesn't cover this. Because if I go start to back, we'll talk about why that is in a second. Alright, so my next 2 are not on your paper. Actually, my next 3. So what I'd like for you to do on your own paper is I'd like you to do this example that I have. It's not on your paper. This is why you're doing this one on your own paper. Example 3, it says, water flows into an empty reservoir tank at a rate of 3,000 plus 5t gallons per hour. What is the quantity of water in the reservoir after 5 hours? Now today is the day where we're going to use your calculators a lot. This is one that you can use your calculators on. You do need to show the setup on your paper. Talk to each other and figure out. If you figure out 3, you're going to go to example 4. I'm going to make. Cassie, what'd you write for example 3? Yeah. T because it's T equals please note she actually told me gallons was a beautiful measurement. That is fabulous. That's exactly what I want. Absolutely fabulous because that gave me the total change in the tank. So let's talk about the 4 examples that I have for here for example 4. I want you to hold up a 1 if you think it's a derivative and a 2 if you think it's an integral. Ready? A 1, I'm going to read it out to you. A 1 if you think it's a derivative and a 2 if you think it's an integral. Okay? Velocity of a train. Hold them up. Oh, good, because velocity represents derivative, rate of change. Rainfall during a 6-month period. Oh, because that's a total amount. Miles per gallon in an automobile. Miles per gallon. Rate of change. Increase in population in LA. Total change. There we go, look at that. Derivatives versus integrals. Alright. Example 5 is not on your paper, so you're doing this on your own paper. And it says, at 7 a.m., the water begins leaking from a tank at a rate of 2 plus 0.25 gallons per hour. 0.25 T gallons per hour. T is the number of hours after 7 a.m. How much water is lost between 9 and 11 a.m.? Again, you're going to use a calculator. I'm going to give you 1 minute.
No, it's not. Yeah, like it's not on that. Oh, duh. Yeah. Because you're starting at
Violet, what you guys get for your equation? Now, by the way, did you all realize she said 2 to 4 and not 9 to 11?
yeah.
Did you? Hours after 7 a.m. Violet, what'd you get? It is because it's leaking, right? Is that why you think it's negative 5.5? So I'm going to bring up what John just said. John brought up a really good point, and we're going to talk more about this when we talk about relative rates a lot. This is talking about the water that is leaking out of the tank, yes?
Yes.
And when you think leaking out means you're losing, which reality is this rate of change is actually negative. This 2 plus 0.25 T, that whole thing is actually negative. That's the rate of change is negative. But the word in the problem says how much water is lost. So the word lost means what? Negative. So it already takes care of that negative for you because the word lost already means. If I had said how much water is changed, how much does the change, then I would be negative. But because it says water lost I already recognize that's a negative. We're going to talk more about that. We'll go more into that in the next unit. Alright, now this is on your paper. I'm skipping a problem and doing this one. It's on the bottom left-hand corner of your paper. And I'm going to make, Augustine, can you read for me, please? It is, example 4.
Taken out and placing himself at 72 degrees Fahrenheit of room at top T 0. The coffee holds at a rate of 16 E to the negative 0.112 T degrees Fahrenheit type room. To the nearest degree, what is the temperature of the coffee at
Alright. In your groups, I want you to talk. Do you all recognize the fact that this is a what? What is 16? E to the negative 0.112 T.
Rate of change.
Rate of change. Which means it's the what? How do I say rate of change? Derivative.
Yeah.
Yes, it is. It is the derivative of the temperature with respect to time.
Yeah.
So instead of it being dy dx, it's d capital T over d lowercase t. Capital T is temperature, lowercase t is time. What am I going to do with that rate of change?
Interval.
Okay. That was just weird, but okay.
I don't know.
Integrate is what you're looking for? I want to integrate this. But Miles, what am I going to integrate it from? Am I just going to straight integrate it, or am I going to have numbers?
I think you're going to have to integrate it from 0 to 5.
Why?
Because we're talking at a time of 5 minutes.
Okay.
So we're starting at 0.
Right.
And then we're trying to find it at 5.
Okay. So I'm actually going to talk exactly what Miles just talked about. He's like, we're starting at 0. And we're ending at 5, but he said we're starting at 0, and the temperature at 0 was 212. I'm looking for the temperature at 5 minutes. How would this give you that?
You just
number that you subtract. So you plug in and then
you plug it into the original point.
So Emma, what are you subtracting from what?
so if you plug back into the calculator,
Right.
then you'll get around 61 if you round it. And so then you're subtracting 61 from the original temperature of 2.
Oh, so
One.
I have a question for you. 2 things. By the way, I would give you. You should give me the decimal. What is the decimal for the 61?
5.
So this gives you 150.744.
256, not 5.
So it was 150.744.
744.
Which, by the way, is this answer. I said to Emma that on my answer choices, 61 degrees would be there as an answer choice. Just an FYI. And they've done that on the exam as well. They had to put that there as well. 2 things I want to talk about. Number 1, the coffee is cooling at a rate of 16. If it is cooling, what does that tell you about this rate?
It's negative.
That's where this is here. Hey, I have a question. What was this again?
Starting temperature.
So what's this? Could I call that my initial value?
Sure.
Yeah.
We're going to talk about that in just a second.
Oh,
All right, let's talk about this one. This one's right above there. All right? This one's right above, and I want you to read this, and then I'm going to ask you a question. I want to give you about 15 seconds to read it. You look at your answer choices. There, in your answer choices, 3 of them are similar and 2 of them are similar. Okay, so hold on. So Emma, what did you say? So let's talk about eliminating answers. Before we go any further, let's talk about eliminating answers. This is multiple choice. Let's eliminate some. So, can I eliminate the W prime or the W? W prime. Why W prime?
Because that'll just give you the.
What is this, ladies and gentlemen? What is W?
Oh, the rate of change.
Oh, it's already the rate of change. It already is the derivative. Do I need to derive that? Because that would give you the second derivative. Hey, guess what? Those 3 are off. So now I have only two choices for myself. Yeah, that's a lot easier. So now let's talk about how without even doing math, can I figure out which one it is? By not touching your calculator. No, it's calculator problem. By just using vocabulary. Yes. John, what?
It asks when the line is getting shorter,
Okay.
and the box office opens at T to 0.
Uh-huh.
So
What do you guys think?
I don't somehow.
John.
Well, let's talk about what John said. John said, I want to talk about when the line is getting shorter. Hey, by the way, if the line is getting shorter, what does the rate of change have to be? Negative. If the line is getting shorter, the rate of change has to be negative.
Yes.
Is everyone okay with that? Okay. Well, I have a question for you. What's W of 0?
It's time.
What's W of 0?
Positive.
It's positive. So is W0 going to be, is 0 going to be one of the values then on my integration? If at W of 0, I'm already positive. No.
Okay, think about it. Store opens. The line's like a so it's starting at 800, like starting at 80 people, right? They're waiting in line, but as time goes on,
Literally, if this was a multiple choice question, there would be my response. There would be my work. Because I've eliminated 3 of the choices, I'm down to 2. Because W0 is positive, therefore 0 cannot be one of my integration ones. Because I know WC has to be 0 in order to be talked about these. It has to be negative, and it's not. It's 0. So that's not out. That's out. That's why we're getting the other 2. So notice we did not even touch our calculator to do this one. So let's talk about example 8. Example 8 says this is, it's not your example 8, it's your example, it's your next one, example 5.
Yeah.
It's your example 5. This example says, I have the graph of f prime over here. And the derivative graph, and it's shown in the figure to the right. And I said f of 0 is negative 1. Can you find me f of 1? Well, I want to work through this one because I want to show you a couple things. Here's my question for you. If I integrate f prime of x, and I'm going to integrate it from 0 to 1. There's a reason I'm going to integrate f prime of x from 0 to 1. But let's talk first of all, if you integrate f prime of x, what do you get? F of x, right? So f prime is the derivative. So if you integrate the derivative, you get the original function. Well, let's talk about why I chose 0 and 1. Why did I choose 0 and 1? Because I gave you f of 0, and I'm looking for f of 1. Well, do you agree that this integration would be the same thing as f of 0, f of x evaluated from 0 to 1? Doesn't this mean f of 1 minus f of 0. Is that not the same thing as this? Yeah? Because that's just the value, right? It's still the same thing as this integration. I'm question again, what was I solving for? What was that? F of 1. Can you solve for f of 1 on this? I moved the f of 0 to the other side. Yeah, I have a question. F of 0 is also known as, anybody know? It is negative 1. That's not what I was looking for, but it is negative 1. I do agree with that.
A.
No. Oh, you can talk about it being f of A, but we'll talk about what it is. So I'll come back to that question. I will come back to this question. I have a question. How do you find the integration from 0 to 1 of f prime of x dx?
Yeah.
I have the graph. What does that mean I can do? Huh? Yep, somebody said it. Cassie said area. Isn't it the area from 0 to 1? Hey, what figure is this? It's a trapezoid. It's straight up a geometric figure. So I can find the area of a geometric figure. That is 1/2 times the height, which is 1, times base 1, which was 5, and base 2, which is 1. Which is negative 1 plus 3. Which is 2. Now, let me go back to the question that I had asked earlier, and I got the response that I wasn't thinking of. F of 0 is my initial value.
Yeah.
The integration is my change, my total change. And I get right and up. If you look on the top left-hand side of your paper, right here, give me 1 second. Right here at the top left-hand side, here's that total change theorem. F of B equals F of A plus the integration from A to B of F prime of A x dx. So F of B, if I want the end result, I can take my initial result plus, or my initial value plus the total change. Hey, down here, on example 6, or your example 4, I think it was. Initial value plus the total change gave me my ending value. Initial value plus the total change gave me my ending value. Let's talk about it in terms of velocity, position, and acceleration. And all of these words you've heard before, and you actually know these. But if I'm going from velocity to position, that means you've integrated velocity. Well, if I want my final position, I can take my initial position and add to it my change in position. So I can take my initial position and add to it my change, and I get my final position. Now keep in mind that is displacement, that is not total distance. Okay? And I can do the same thing with acceleration. Now here's the totally new piece. If you remember us talking about total distance, we have talked about it having to talk about absolute value, yes? Because that was your 3 steps forward and your 2 steps back. Or your displacement was 1, but your total distance is 5, because your 2 steps back is negative, and that's absolute value. We talked about how you had to do the absolute value. You had to know where the velocity changed direction, yes? Remember, we talked about it, for example, if I was going from 0 to 5, and my velocity changed direction at 2. I'd have to talk about f of 5 minus f of 2, the absolute value of that. plus s of 2 minus s of 0. The absolute value of that. So that I can get the distance, the two separate distances, and add together. There's a way to do it with velocity, with integrating velocity. You are going to integrate the absolute value of velocity. With a calculator, you can do a straight shot. If you're not doing calculator, you have to split it up into two separate integrations. One positive, one negative. But in this calculator, it is literally the integration of the absolute value of velocity. Now keep in mind, those absolute value symbols are inside the integration. They are not outside the integration. And here's why. Here's why this works the way we're talking about. Let me ask you a question. I'll put it on here. Velocity graph. Okay? Everyone okay with that being my velocity graph?
Yeah.
If we're talking about distance traveled, the problem with this distance is it's what?
Negative.
So when I talk about absolute value, what absolute value is going to do is it's going to come here. What does absolute value do graphically? To this graph. It will keep everything positive and it'll make what?
It'll make like a W shape.
Because what does this piece have to do?
Positive.
Flip up. So it's literally going to do this. So it's literally taking this piece and putting it up here. So this area that's down here that was a negative area is now considered a positive area. That's why. Okay? And then I have a positive area and then positive area. That's why I'm getting this positive piece. Is everyone okay with that? Alright, so let's talk about how to use it. You have this example on your paper. It's on the next page. It's on the bottom. Yes. Did you find the equation of the line and then integrate that? You totally could have done that as well. Alright, I'd like you to do this example in your groups. Yep. You should have gotten for this one. You ready for it? 31.5. If you got 13.5, did you get 13.5 but not 31.5? 13.5 is the area. But the problem is that it started at 18. So it was 18 plus the integration from 0 to 10 of v of t dt. Which makes, I did a trapezoid, what's my height, 3, and 3 plus 6, plus a triangle, which has 1/2, that's 3, negative 2, negative below the x-axis, and then 1/2 of 1 and 6.
It gives you the gives you v of t and v of 1 is equal to 25. So you find lots of function and you just do that. Solve your scheme. And then you get the velocity function, and then this is the original function. This is just like the chain. Right. It's just like the integral. Right. Okay, I see. Yeah. So that might not be good, but I get that. I might not. Here you go. That's why there's like.
Alright. For example 10, or whatever example, the next one. Here's what you need to do for the next one, just an FYI. You have to integrate and get the plus c first. You have to integrate acceleration and get velocity. And then I plugged in 1 and 25, 1 for c, 25 for v. And I got c to be 20. So then that is my velocity equation, which was 18 minus 3t squared plus 20. And when I integrate velocity, I get position. When I integrated velocity from 2 to 4, I get position. That's position evaluated from 2 to 4. That's s of 4 minus s of 2, which is literally the integration of this. The integration of 8t is 4t squared. The integration of this is negative t cubed. The integration of this is 20t, evaluated from 2 to 4. And then you're just plugging in.
Yes. Integrate the function by itself.
Yes. You can totally integrate the function by itself and then go from there, yeah. In the interest of time, we're going to do one more. I want you to do the next one. Yes.
So, I'm finding the s and the word having to see it.
No. Well, you could, but when you have a definite interval, definite interval don't make sense. Because I'm integrating velocity in particular numbers, I don't want to worry about.
I got 0.
Oh. Next one. Number 8. It's a total calculator problem. You just have to show the setup. By the way, what mode should calculator be in? No. You better be in radio mode.
What did you get, my dude? I didn't get it. You sound like you.
Do you notice that A is on there, 0.163?
Yeah, it's not.
That's not it.
Yes, I see.
So just an FYI, please make sure that you recognize that speed is the absolute value. I would have put negative on there for a choice as well, personally. Okay, question 4.